Alright class, so we have gone through the batching process, we've gone through the milling process, and if you remember from where we left it off, there was quite a bit of ethanol in our samples, and so we put them in the drying oven. So fast forward to now, and we're going to take out the dry samples and take a look at what it looks like and get it ready for calcination. So I'm going to open up the furnace with my gloves on, and I'm going to take out our samples. So if you recall, these were drying at 78, which again was a significant temperature because that should be near the boiling point of ethanol. Therefore we get rid of that, but not at a too drastic of a rate. So I'm going to take these over, which are for Monday A and Monday B. We are going to take these over to the fume hood, where I'm going to show you what it looks like, and we're going to sort of break up these large clumps a little bit before we do the calcination step. Alright, so we have the powders out of the drying oven. All the ethanol is gone at this point. So I'm going to show you what they look like. So these are Monday A and Monday B's powders that we're making. And so this is what the sort of top looks like. So you can see a little bit of differences in color from these. And then it's also kind of one big chunk at the bottom with some cracks in there, if you can see that. So what I'm going to do now is I'm going to take the spatula that I've cleaned just like before, and I'm going to scrape off stuff from the side of the beaker. And I'm also going to try to break up, as best that I can, these large chunks. So basically at the end of this, I hope to have something resembling a powder. It should be uniform from our milling and then from this process. And then we are going to weigh it, and we're going to weigh the crucible before we put it in the furnace, so that we have a nice record of the mass of the powder before we put it in. And then we also know how much the crucible weighs. That way, when we get it out of the furnace, we'll know how much everything weighs. So, if you can kind of look at it now, so you can see I'm breaking it up, and beyond that sort of top surface layer, it's very uniform. And so more or less what I'm trying to do is just get rid of these big clumps before we go to the next step. So that's really all I'm doing. And there's also some at the bottom. You can hear the annoying scraping of my spatula. That is what that is there. So there's still a few little clumps here. We're not going to worry about them too much. As you'll see when we get the samples out of the furnace. So this is what it's going to look like. What we're going to do now is we are going to go ahead and stop this for a bit because we've got to do the other one. But then we are going to weigh out the amounts. So we're going to show you what that looks like. And we're going to put them in the furnace to calcine for creating that YBCO powder. So we'll be back in a second. Alright, we're back after a short break. So we have the powder back into a nice form. And so what I'm going to do now is I'm going to get the powder ready to go in the furnace. And so what I'm going to do is we've got these large crucibles, and this is where we're going to have our powder calcined. So this is able to hold all of our powder. And so what I'm going to do first is tear the balance like I've done before. This one is called zeroing, which is better in terms of verbiage because I am very confused about that. I'm using this slightly different balance. It's open air, mostly because these crucibles that we have are pretty heavy. And so we can't have this plus the mass of the powder on the other balances. And so we're going to use this one. So it's not quite as accurate as the other one. So if you can zoom in here, Antonio, to kind of see that there's some variation, particularly with the wind, the current that's going on in here with the fume hood. So there's a little bit of, there's going to be a little variation in this one. So this is the best we can do with these large amounts. So putting on the crucible, and this is for Monday A. So if you'll have the video here to see what the mass of your specific crucible is. So that looks good. All right. So we've got the crucible mass. Now I'm going to zero it again. That way, the next mass that I see is going to be the mass of the powder that I'm adding to this crucible. So a little bit more consistent now, but still a little variation. So now I'm going to try to be as careful as possible, and I'm going to pour this powder, which belongs to Monday A, into the crucible. So for all the other groups, we have done the same process, but instead of a video, you just have pictures of us doing this process. So just a note for everybody following along at home. So this is also one of those times, once we get the mass of this ready to go, to start thinking about all the things that we added in terms of those 3 ceramic powders, and think about what the mass should be at this point, right? Because we've gotten rid of all the ethanol, and so what's left should just be those 3 powders: barium carbonate, yttrium oxide, and copper oxide. And so whatever we have here, should match that within, our error of how much has been lost through this process, right? So that's kind of what you should see at this point. All right, I've got a little bit more at the bottom, so I'm going to try to scrape that from the bottom without blowing off all of our eardrums here. Just to get you as much powder as I can. There's always going to be a little loss here in each of these processes. I'll try to minimize that. All right, probably as much as I can get without spending all day here. All right, so you can kind of see a little bit left over, not much, but a little bit. And so you can also kind of zoom in here for the mass. And again, think about the powders that you've added, and think about the mass that you have here. And again, this is for Monday A. And so for Monday A, you can take this mass as your mass of powder going in for calcination. All right, so I'm going to set this one aside, properly labeled. And we're going to stop the video, and we're going to do the same thing for Monday B, but we're just going to take photos of it, and we'll be back in a second, and I'll show you the process of calcination. All right, we are here to take Monday A and Monday B's powder, put them in the furnace for calcination. So we've just gone through the weighing and so forth. So the powders are in your crucibles. So I've got Monday A, Monday B. So again, just kind of take a note of the physical appearance, color, how big, how much volume it takes up, right? And so we will look at these after. So I'm keeping track of these, A, B. I'm going to open up the furnace. I've already got it labeled, so I'm going to put Monday A on the left and Monday B on the right. I'm going to try to keep them pretty close to the middle so that they're experiencing the same temperature in both cases. So I've got them there in the center. I'm going to go ahead and close the door. The furnace is off right now, So we are going to take a short intermission and get it set up, and we will show you the procedure for setting up the program for calcination. And so we'll take a short break. We'll be back in a second. All right, we are back. Monday A and Monday B's samples are in the calcination furnace, which is this one. It is off right now. It is cool. And so I'm going to walk you through the calcination process. This is going to be the same for all groups. We are not changing this as a variable, so it's going to be the same. And so we're going to walk you through the calcination steps and how we program that on the furnace. So first things first, as you might imagine, I'm going to power the furnace on. This is a thermoline furnace. So you'll see on the screen here, the first things you'll notice is that on the bottom it says 0, and on the top it says 23. So the top is always the actual temperature that the thermocouple inside the furnace is reading. So it is 23 degrees, again, so it's safe to touch. The bottom is the set temperature. So it's set at 0 right now. It can't actually reach 0, and so it's just gonna go as low as possible, right? So there's no cooling inside this furnace. What we're gonna try to do with this program is set it up so that it's ready to calcine. And so for us, for YBCO, for this solid state reaction, this procedure we're using is we're going to heat up to 940 degrees Celsius, and we're going to do so at a rate of 10 degrees C per minute. So we're going to heat up 10 degrees C per minute, hold at 940 Celsius, and we're going to hold there for 12 hours. After that, we basically switch the furnace off and allow it to cool naturally. So that's called furnace cooling. So we don't do anything else, we just basically switch off the heating elements and allow the thing to cool down naturally. So this is going to be really slow because we are not opening up the door or anything. It's still pretty well insulated, and so it ends up being a fairly slow cooling rate. And so we're going to get that set up for this program. So in future videos, when we go through the sintering process, I'll walk you through similar programs for those as well, so you can kind of see what's happening in those programs. All right, so the first thing we're going to do is we've got 4 buttons down here, and then we've got 2 up there. I'm going to ignore those for the most part. So really all we need is these 4 buttons. I do not know the names off the top of my head. These are up and down, obviously, but these are our main kind of buttons to program this furnace. And so what I'm going to do is hit the first one on the left, and you'll see that that changed. And I hit it again, it says run list. If I hit it again, it says program list or prog list. So that's what I want. And then I'm going to hit the second button, and it says program 1. That's how you're reading this thing. So program 1, spoiler alert, I've already programmed to do the calcination process. So I'm going to go ahead and hit the button again, and it's going to walk through all the steps. HB, again, I'm kind of bad at this, so I don't know what that is off the top of my head. I can get back to you if you are interested. HB units, 0. And then this is the more important one. So we want to read this as ramp unit, and that's going to be in minutes. So basically degrees per minute. Then we're going to have dwell units and hours. So anything we want to dwell, we're going to say that in hours. And then cycle number, that's going to cycle once. So basically we don't want it to repeat the program that we're going to do. So we only want to have 1 cycle. And then we get to the actual segments. So this is segment number 1. And so that's where we're going to start with. And you see here the type of segment this is a ramp rate. So the little R here is for rate. And so I'm going to click it again. And it says, the next screen is going to say, it actually wants us to tell us the target first. So TGT is target. So our target is 940. So we're going up to 940. And then the rate is 10. So again, since our units are in minutes, this is 10 degrees per minute. All right, so that is my first step. Segment 2 is now going to be a dwell. So type dwell, and I go to the next screen, it says hours, and then you see it automatically switched over to 12, and that's again an hour. So it's gonna dwell at 940 for 12 hours. So that's all set up. Segment 3, type, this is a step, which means it's going to try to get there very quickly, and that's going to be set at 1. So basically, we're setting it to the lowest possible temperature, and so the furnace has no control over that, and so that's just going to make it cool naturally by however fast the furnace can do it, and that ends up being very slow. So that's kind of the program that we have. Segment 4 is end, so basically it's done. And so once it's never going to reach that end point because it can't get down to 1 degree Celsius, right? Because that's basically freezing. And so that's kind of how this is set up. Antonio, can you bring it back over just for 1 second? So since we didn't have to change anything, I just want to show you real quick. If we did want to change something, so let's go to the the target temperature. Let's say I wanted to change that. Once it reaches the screen, if I hit these up and down buttons, right? So then I can adjust the temperature. And then when I do that, you have to wait for that little blink to happen. That means it's set. And so then you can go on to the next screen. So you have to wait for that blink to occur. So if I want to do any of these changes, the up and down arrows are how I use that. So for example, if I want to change the type from a dwell to something else, I can do that here, right? So that's what the up and down do, and you always want to wait for that blink. All right, so we've got this thing set up. I'm going to scroll through all of these things again, and then I'm going to go back to the first button that I was pressing on the left, and I'll cycle through stuff. Then now I want to run this program. So what I'm going to do is I'm going to go to Run List, and then I'm going to hit the second button. That was program 1 that we were programming, and so I'll go through that again. And then this is the status. So right now it is off. So if I want it to run, I click up, it will blink, and then it will be running, and that's it. So now we'll go back. This is also telling us the programs again. So if I go back to the first button and cycle through, now you'll see a little difference here. You'll see a thing blinking in the top left. That means whenever it's blinking, that tells you that the heating elements are operating. So it's trying to actively heat up the furnace. And then same as before, the top temperature is the actual temperature, so it's still at 23. And then the bottom temperature, you can see that, you might have moved, right? It's 28 to 29, so it's actively heating up. So that's what it's trying to achieve. So early on here, they won't match very well at these low temperatures because it's still heating up, right? So it takes a minute, but eventually the temperature will match up with the set temperature very nicely when it goes through. So basically this is going to tell you what it's trying to get based on our ramp rate of 10 degrees per minute. All right, so this is all set to go. You can kind of run through those numbers and think about the temperature and the dwell time and the ramp rate and try to figure out for yourself how long this is going to take. But I'll give you a spoiler alert, it's a long time. So we won't do anything with this today. So this will be all set up, and we'll come back here when it's finished, and we'll show you the end product. So that's all I wanted to show you about programming for calcination. All right, we are back. This is post-calcination. So we've gone through the procedure that I've talked about for calcination, and we're going to get the samples out. You'll probably noticing that I'm using these nitrile gloves. That is because this has been cooling for a very long time. If it had not been, I would be using tongs or thermal gloves or some combination of those. So don't be alarmed by these. These are have been at room temperature over the weekend. So I'm going to open it up, and we've got our crucibles in here. You'll notice 3 crucibles. So these are the samples that were done by Wednesday A and Wednesday B before the lockdown. So those powders were made by them. We put them in the furnace for them. And we also have a third one, which Nancy did to try another condition, which will not be part of this experiment. All right, so I'm going to bring them out, and I'm going to show the camera just what it looks like after they've been calcined for this procedure. And so I will take one out at a time so I do not get them mixed up. This is Wednesday A, and if you kind of look inside there, and we're adjusting to a new camera, so Antonio will do a good job of that. You'll notice that there's a big difference in the appearance post-calcination. So kind of note the properties that we have there and the differences in there. Compare that to the stills or the video that you have for your group's powder before you put it in the furnace. So you'll have those videos to compare to. So this is what it looks like. So we are going to take this out. We're going to take all these out and take them over to the balance, and we're going to weigh these. So we'll have a mass of the crucible plus the powder, and I'm going to do that together just in case there's some stuck to the sides. So you'll have one mass for both of those. So we'll take a quick cut here, and then we'll be back to weigh these. All right, we are back. We've got the calcined samples out of the furnace, and so we're going to have some pictures of those, and you'll see those with the stills and so forth. You saw them coming out of the furnace. What we're going to do now is just a quick video showing you the weight procedure. Nothing too drastic here. We have the samples plus the crucible, right? I didn't separate them yet because some of it is stuck to the sides. So I want you to have a weight of what came out of that as well. So I'm going to zero the balance. Again, this balance is a little different than the other ones because of the weight difference. So I'm going to take Wednesday A's sample and put it on. So again, this is the mass of your YBCO powder plus crucible after the calcination process. So make a note of that mass, and we will have the masses of the other groups, Wednesday A and the Monday groups, on photos. So everybody else can just look at the stills for that. All right, thanks.